morning, all of you, the different participants at the centers and those who are here. So the teachers, the participants here also, I welcome you for this lecture of mine. I am Dr. Lini Methew, working in the electrical engineering department as head of the department. I'm working in this institute for the past 30 years. I've been teaching this soft computing techniques, neural network and fuzzy logic for so many years for the electrical engineering students. I'll give you a general overview of what is soft computing and what are the different techniques. Mainly, I'll concentrate on neural networks and fuzzy logic so that you will be able to use these techniques, including using with the optimization, GA, PSO, all what you learn, because this is a course on optimization. So you may require to use this as hybrid techniques. We all know and we are familiar about conventional or hard computing. Whereas nowadays the name is on soft computing. How is it differs? It is tolerant of imprecision, uncertainty, partial truth, and approximation. See, many a time when we have hard computing, you know, you have an equation, any quadratic or third order equation, you have values and you will get a result. Or for differential equations also, you have values, substitute, differentiate, substitute, you get the values. But in there is no tolerance for imprecision or uncertainty throughout. So there we have to go for optimization techniques and soft computing techniques. So that is the main difference of soft computing, where we make decisions and take into consideration partial truth and approximation also. So the main tools are fuzzy logic, neural networks, support vector machines, evolutionary computation, machine learning, probabilistic reasoning. So these are different methods or tools which we use for soft computing. And optimization techniques, different optimization techniques are also soft computing techniques only. So the guiding principle of soft computing is to exploit the tolerance for imprecision, uncertainty, as I told you, partial truth. So we exploit how we can do it so that we can achieve robustness, tractability, and low solution cost. So as I told you, neural network, fuzzy logic, SVM are the different methods. Okay, so these are actually complementary. One complements to the other. So we will see how it does it. So a particularly effective combination is the neuro-fuzzy. We can combine these together. Genetic neuro, neurogenetic, neuro-fuzzy. So we call them as hybrid systems. Hybrid systems where we combine these techniques together also. Okay, so they become increasingly visible consumer products. So many of times such systems we can use for products also. These days, nowadays, we have consumer products using this, air conditioners, washing machines, where these techniques are employed. So we'll again go for some more details of it. The main criteria here is learning from the experimental data. We have some experimentals and we have some data, and we can learn from that data how the same system will behave in the future or behave in similar situations. Okay, so there is a power of generalization. See, I told you we have some experimental data, and how that data is behaving, from that we can generalize the behavior of that system. Okay, so usse for approximating, interpolating, yes, to produce outputs from previously unseen inputs. by using outputs from previously learned inputs. So we have some inputs, we have some experimental data, previously learned inputs and outputs, and from those data we will be able to define or come to conclusion of the behavior of the system. Okay, so generalization is one of the main property of soft computing devices. So these are the various techniques. We will see one by one. First, I'll deal with neural networks, basics of neural networks, and then we'll go on to fuzzy logic also, and some portions of genetic algorithms and PSO and things like that. When we talk of neural networks, see, neural network is a word which characterizes to the human brain. Neuron is the basic cell of a human brain. So biological neuron, what are the characteristics of a human brain or a biological neuron? See, it can learn from experience, it generalizes the knowledge it possesses, and it can perform abstraction. Abstraction means partial truth or half correct inputs. It can come to right conclusions. You know, our human brain is very capable so that we can come to right conclusions even if we have half truth. Okay, so many a times, you know, objective type questions mein bachche right answer A B C D mein we know what to click, means hame tukke laga sakta hai. So we are very good in it. So that capability of human brain is not there when we go for machines to work. See, a very simple example I tell to my students is like Diwali ka din Chandigarh mein bahut rush hota hai. Jagah jagah all signal lights, so much cars and so much of traffic. उस दिन ट्रैफिक सिग्नल ऑफ करके पुलिस को खड़ा करता है, ट्रैफिक पुलिस को. भाई सिग्नल से काम नहीं चलेगा. Yes. There the human interference is important. Human intervention is important. Real-time decision making should be there. See, सुबह पंचकुला से बहुत गाड़ियां चंडीगढ़ को आता है. चंडीगढ़ से ज्यादा पंचकुला को नहीं जाता है. So, equal time to all directions may not be useful. More time should be given to one side. Such decisions can be made only by human beings. So that human intervention is very important when we make machines do things. आजकल mechanization, automation means उसका जमाना है. But वो intelligent decision making will the machines be able to do? There really a simulation or emulation of a human brain and decision making is very important. So neural network, even though last point mera dekho, to make, even though human beings make errors and machines may not make errors, but the solution is that these capabilities of human brain, the three capabilities only I have not listed out, you can have so many capabilities. If we can emulate these capabilities into machines, when I say machines, it can be a computer or a microprocessor or a robot, whatever it is, whatever machine you wanted to do work. So it is like we simulate the human brain or the capabilities of the human brain. See, just like that, to understand, there are around 100 billion neurons in our brain, and all these neurons are interconnected, and these neurons are responsible for our thought, emotion, learning process. Cognition means learning, retrieving, memory. All these are mainly these neurons and its connections. These are interconnected to each other. Some of the pictures I've taken from internet. So it looks like it has one neuron. It is a picture of one neuron. It looks like a tail-like structure. So it is the fundamental building block of the nervous system. And this neuron performs all the computational and communication functions. What do you mean by communication functions? Because each of these neurons communicate with each other. Informations are passed on from one neuron to another neuron. And this is a many input, one output structure. All these tails, they call it as dendrites. All the inputs are known as dendrites and the outputs are known as axons. So for each neuron, there are so many dendrites and one axon and a cell body and a nucleus. So the axon carries the signal away from the cell body and dendrites carry the signal into the cell body. Okay. Each of these neurons are connected to each other and these are the connections. The connections are known as synapses. These are synapses. Okay, otherwise we call it as synaptic connections. And actually the connection, how the information is passed on is by means of neurotransmitting molecules. So these are in ionic form. So these ions move from one form to the other form. And you know there is an ion movement. I don't know, you know that there is an ion movement, there is a charge. There is a flow, there is an electro EMF produced or a potential there. So there is always a potential or a voltage. That is why we could measure these potentials by means of ECG or EEG or EMG. There is a potential difference between these neurons from one part of the body to the other part of the body. Okay, let me go fast. So, what is the conclusion? If I compare computers and human brains, both operate on electrical signals. Both are composition of a large number of simple elements. And both perform functions that are computational. So, a neuron also performs computational functions and it communicates from one element to another element. Here also in computers also you can compute and you can communicate also. So why can't we emulate these capabilities into a human brain, the capabilities of a human brain into a machine? Okay, that's what we are going to do, how we will do it. But then there are some differences. See, the computation, microprocessors or computers or microcontrollers work on microseconds or nanoseconds time scales, whereas our brain is very slow. We think we work very slow. We are very slow. So they are very fast. Digital computation or digital machines are very fast. But then the brain's computation is huge. It does these computation by having a tremendous number of parallel computational. I told you there are 100 billion neurons and all these are connected together. So this computation is a huge computation rate, whereas any computer system cannot do that amount of computation so fast. So here the computation rate is faster, more in a human brain. Another thing, even though digital computer is inherently error-free, but brain often produces best guesses, approximations from partially incomplete and incorrect inputs. See, for any computer program, you give a wrong input, you will not get a correct output. You write a wrong statement, wrong program, you will not get a right output. But human brain has a capability that it can work, it can do best guesses and approximations so that it will give you a right output even though your input is partially incomplete or partially wrong. Okay. So now let us start with a simple neuron. I told you our neuron, which I had shown you previously, is a many input, one output unit. So let us now consider a simple neuron with many inputs and one output. Okay, you can see this. So there are now n inputs, I1, I2, I3, In, and these are given to the neuron, and the neuron is giving us one output. Now what computation is it doing? Each of the input is associated with a weight W. Okay, each of the input is associated with a weight. So usually I define this weight as an importance of the input. Okay, each input has an importance. So I1 W1 plus I2 W2 plus I3 W3, that is the computation it does. The input value multiplied by the weight value, and add all those, and you get a net output. So here I have a net output X. Now what is that net output doing? Now we have to take a decision depending on the value of that net output. See, one simple example is, even though this room is very soundproof, we will not hear any sound here. Simply imagine we hear a sound. See, we hear a sound means we will continue with our class. Okay, but if that sound is that big that we feel that the ceiling is falling down, so then we will all run. So depending on what are all the inputs, see, हमने आवाज भी सुना है, ये सब हिलना शुरू कर दिया है, ये गिरना शुरू किया है. So many inputs we are having, sensors, all our sensors are having different inputs, I1, I2, I3. And each of these inputs are having a weight W1, W2, W3. So the net output is actually the multiplication and addition of all this. Now, depending on that net output, we will decide to run from this room. Okay, 1 or 0. When is it 0? But let us continue with the class. So we have that net output is X value, and we do we apply an activation function to it, whether we have to get an output 1 or get an output 0. Okay, so depending on that X value, here I'm taking an input, I'm getting an output 1 or 0, depending on the value of X greater than a threshold value T. Okay, so that value T is important. If X is greater than T, then we will run from this room. Otherwise, we will sit here, 0. So if we are running or the output is 1, means the decision is excitatory, excitation. If it is 0, we call it as inhibitory. What is inhibit? What is the meaning of inhibit? What is the meaning of excite? Excite ho gaya, bhag gaya. Inhibit means kha liya, chup baith gaye. So depending on the output, X is greater than T or less than T, we take a decision. So here in simple neural network, we have only one output, and we think that output is 1 or 0. We call it as a binary output or a bipolar. So this is a very simple neural network we have designed, and usually we call this as McCulloch-Pitts neuron model. I'll come to that. Now, one of that example which I have shown you, which we call it as threshold function. Greater than T means 1, less than T means 0. But it may not be the story every time. We cannot define all the decision making as 1 or 0. We may have to take values in between 1 and 0 also. So we may use other activation functions also. This is an activation function, sigmoid function, squashing function, logistic function. We call it different names, but the output can vary from 0 to 1. It takes values in between 0 and 1, depending on the value F or the output X. X, if there here many F likha hai, but actually it is X. Depending on the value X, I will get an output Y between 0 and 1. Here there is a value called A also. How we change it? We can change it gradually. We can change the abrupt change from 0 to 1 also, depending on various equations. Okay. Here, the decision is bipolar, but we can have values between -1 and 1. So the mathematical equation is tan hx, or here it is 1 by 1 plus e raised to minus x. When we use that mathematical equation, we get values between 0 and 1. We get values between 0 and 1 depending on the value of output net value x. Okay. Here it is tan hx or tan hax can be given, whereas values will change from -1 to 1. So these are different activation functions. Now, I told you with a single neural network, we can have values like we can have only one output, many inputs and one output. Many a time when we try to define or design a neural network, it is not that the system for which we are going to design it has only one output. We may have more than one outputs. So then how will we do it? When we have more than one outputs, then we can have more than one neurons in a layer. So you can have many inputs, and how many neurons you have, that much outputs. You have 3 outputs in your system, you can have 3 neurons. And these 3 neurons, all the inputs can be connected to all these 3 neurons, so that you get an output. So when you connect those neurons in such a way, we now call it as a neural network. And when we have only 3 neurons and we have inputs and outputs taken from it, then we call it as a single layer neural network. We call it as a single layer neural network. So we give inputs, we have weight values, we multiply I1 W1 plus I2 W2, we have X values, and each of the neurons we apply the activation function and we take the output. Are you clear? That is how we design a single layer neural network. But we can have multi-layer neural networks also. Okay. In multi-layer, there are different layers between the input and the output. So inputs are given to the input layer, outputs are taken from the output layer, and there are layers in between input and output layers. So you may ask me why. Okay, so here, see, when you think of, see here I have taken an example. Light, temperature, relative humidity, carbon dioxide, nutrient, age, plant type, some inputs are all we are giving. And we try to get an output like transpiration, assimilation, allocation, some values between 0 and 1. And you think that you multiply, add, and apply a neural net, apply a function, you get the output. Many a time, the multiplication may not give you any output. So you may have to have different layers in between and different activation functions in between, so that you get the output. And you may have to have iterative process. You may have to have iterative process of changing the weights and find out the weights which we have put in is working or not. So this is actually a very tedious process of iteration. So simple programs, just when I say, yeah, do this, you feel it is very easy, but it is not that very easy. Lengthy programs have to be written. The iterative process has to be done again and again. And it has to converge to some output values. So we may have hidden layers. These layers in between are known as hidden layers, and any number of neurons onto the hidden layers. Okay, are you following me, all of you? So we have these multi-layer artificial neural networks, and the only consideration here is that these are feed-forward networks. The output of one layer is fed as the input to the next layer, and output of the second layer is input to the third layer, and output of the third layer can be input to the output layer. So it will go on as a feed-forward network. We usually call it as a multi-layer feed-forward network. So each of these layers, we have different sets of weights. Okay, input layer, hidden layer, output layer, we have different sets of weights. When we design a problem, we usually have weights as random values to be put into it. Random values to be put into it. So this can then changed by the iterative process. The random values can be changed into pakka values or final values, which will give you the output from the input. Okay. So this process of changing the weights is known as training. So we require that the neural network has to be trained. See, we are also, see, from our childhood, we are made to learn and practice and train so that we give output. See how our primary school teachers were making us learn the multiplication tables. We were practicing it again and again and again. And I know nowadays we don't recite that multiplication table now. Just like that, 7 8s are, we know it. We are not telling the multiplication table of 7 1s are 7 2s are 14, but we know 7 8s are 7. So that is the process of multiplication, means training. So here also, because we call it as an artificial neural network, we make these neurons learn by the process called training. So now you may ask me, what are we doing during training? I told you it is an iterative process. We have some input values and some output values. So the input, I told you, that is why it could do approximation, it could take incorrect values and all those things, even if it has to take decision making. See, we have some input values and we have some target output values. What we do, we have a random number of weights. So this random number of weights are not giving you the output. So what we do, we find out the error of the calculated output and the target output, t minus y. And that error, depending on that error, we change the weights. With the new weights, again you apply the inputs. Multiply, computation, find the activation function, again find the calculated output, again find the difference between t minus y. Error is then used to change the weights. So that process of iteration is known as training. So when you have a target value t, and every time you calculate an error t minus y, then the training is known as supervised training, because you have a target value. You know what I have to achieve. Okay, but in many cases, that is not the story. आपको एक target value नहीं है. You have to group it or position it. उधर कोई target value नहीं है. कुछ एक cluster है, position है. So you have to change the output. There what we do is, every time you compare the previous output with the present output. Did you get my point? Y1 minus Y2, and that is the error. And that error is then used to change the weights. So then it is known as unsupervised training. There are other methods of trainings also. Commonly we call it as supervised training and unsupervised training. See the neuron which I have shown you, before. I told you one single neuron, some inputs and one output. That is devised by scientist called McCulloch, and so that model is known as a McCulloch-Pitts model. And I told you, and that is not a very efficient model. So we made it changes. We made layer of neurons, single layer or multi-layer. So we call such a basic network as perceptron network. So perceptron is the simplest and the basic neural network. Here I have shown you only one neuron with some inputs and one outputs. You can have single layer, number of neurons, or multi-layer also perceptrons. The only thing with perceptrons is that you use the threshold function over there. If the x is greater than a particular value, output will be this. Less than a value, output will be 0 or 1. It can be binary or it can be bipolar. The output will always be binary or bipolar. You will not have values between 0, 1 or -1 and 1. You will not have all real values as outputs of perceptron network. So perceptrons, because it has values only 1 or 0 and -1 or 1, we usually use perceptrons to classify. I think from the timetable I have learned that you have learned MATLAB. So in MATLAB, if you go and see the demo of perceptron network, it will give you examples of various classifications, banana and orange key classification, or whatever it is. It is perceptrons are mainly used for classification into two groups, mainly into two groups. So usually we make a perceptron network for an AND gate. I don't know how many of you know about AND gates, even if I think you all are mechanical graduates. You have learned electronics, I know. So AND gate has only two values, 1 or 0. It has inputs also, ones and zeros. What are the inputs? 0, 0 will give you 0. 0 and 1 will give you 0. 1 and 0 will also give you 0. But 1 and 1 will give you 1. So depending on the inputs, 1, 0, 0, 1 key combination, you only have two groups of outputs. What are the two groups of outputs? 0 and 1. Same as OR NAND or NOR. All logic gates have only two set of outputs. So whenever you have to classify into two groups, then we use this perceptron network. But we usually don't use perceptron for if you have to classify it into more than two values, zeros and ones, and values between zeros and ones. Okay. See, this is developed by Frank Rosenblatt. You can note it down. This is the algorithm which we use, learning algorithm which we use. I have already explained all this. Weight Wi, input xi, sigma xi wij means x1 w1 plus x2 w2 plus x3 w3. Okay, and you get a net value, and a function, threshold function we are applying on the net value. What is that? Net is greater than 0, y equal to 1, otherwise it is 0. And now if that is not the case, then we change the weight. I told you training. How do we do the training? If output is 1 but should have been 0, okay, that is the case. T is not equal to y. Aapka T 0 hai. Y kya ho gaya? 1 ho gaya. Then what we do? We change the weights by wij k plus 1. K plus 1 is the iteration number, is equal to wij k minus alpha xi. That minus has come from t minus y. 0 minus 1. So we get there minus. Otherwise means if output is 0 and target is 1. So there we use plus. Wij plus alpha xi. Xi is the input. Alpha is the learning rate. you can accelerate this learning process by simply multiplying by a learning rate value alpha. Usually alpha are values between 0 and 1. You give an alpha value 0.2, it will learn slowly. You give an alpha value 0.9, you find that it learns faster. आपका convergence faster आ जाता है. आप कोशिश कर सकते हैं. This is the utility of alpha. Usually we take alpha as 0.6. Okay. This rule of taking the error t minus y or -1 or 1 minus 1 if the outputs are bipolar -1 and 1, or it is 0 and 1, 1 minus 0 or 0 minus 1. Those are known as delta rule. Delta rule, that is the learning algorithm which we use. So I have written the weight adjustment as alpha t minus y xi. Piche bhi t minus y hi tha because it was 0 and 1. When it is -1 or bipolar bhi ho sakta hai. -1 or 1, we have to take t minus y. So it becomes -2 or 2. Okay. Then there is another type of a network, we call it as a back propagation network. This is a very popular and widely used networks. You know, threshold perceptron has the disadvantage that you can use only for classification. आपको output 1 or 0 ही मिल सकता है. उससे ज़्यादा हम नहीं कर सकते. But whereas in back propagation, you can have output values between 0 and 1 or between -1 and 1. Okay, so it is a very popular method used in engineering applications. See, I can give you a good book on neural network and fuzzy logic by Rajashekharan and Vijayalakshmi Pai. Even though I am an electrical engineer, I referred that book, and that book has more examples on civil engineering problems and mechanical engineering problems. That Rajashekharan and Vijayalakshmi Pai. I think Prentice Hall ka publication hai, Prentice Hall ka publication hai, PHI ka publication hai. Means good book on all these things. It explains very well, and those both of them explain it for mechanical and civil engineering problems. Good book. I could get the basics cleared from that book only, and because those are the examples which they speak out are civil engineering, King post trust roof ka examples and all they give, because that is not relevant for me. I used to use it for electrical engineering problems, but the explanation is very good. For you people, you can go through that book actually. So here in back propagation, we have a multi-layer feed forward network. And in those multi-layer feed forward network, we use the activation functions like sigmoidal functions in between. We don't use the threshold functions here. We use tan sigmoidal and log sigmoidal functions in the training process or the activation functions in each of the layers. See, I told you there are supervised training when we have a target, and non-supervised training when we don't have a target also. So in cases like counter propagation network and all, these are actually self-organization networks, like SOMs, self-organization maps. See, in self-organization maps, it learns from the unsupervised technique. It organizes अपने आप वो organize हो जाता है, self-organizing. It does not have a target that they should be there. Does not have a target. So in such cases, what we do is, in one layer we use the supervised training, in another layer we use unsupervised training. So that is why the name counter propagation networks. In Hopfield networks, these are different networks. Ajkal means in 1 hour, I will be only able to give you names of these. But then if you go, I told, that's why I've given you references of books where you will get really good explanations of this. In a Hopfield network, Hopfield network is actually a feedback network. These are mainly used as memories, remembering things. We call it as associative memories. What do you mean by associative memories? What do you mean by associative memories? See, imagine I have so many students, but I remember a student because he's from mechanical engineering. मैंने वो associate किया ये mechanical engineering का student है. Or another student I associate that ये south से है, Tamil Nadu से है. So we keep associations to remember. Our brain keeps associations to remember. Some or other, you can associate so many things. I have seen students in 10th and 12th to learn essays. Each paragraph की first words की वो एक slogan बना के रख देता है. तो उनको पता होता है क्या क्या उसमें लिखना है. वो एक slogan याद करते हैं. So you associate things. Similarly, here also, the network associates. One association I'll tell you is fingerprints of a person. So the network is trained for the person's name and their fingerprints. Imagine the police is having 1,200 fingerprints and their associate Choron ka number. Now, so it is trained now. Got my point? Now when it gives a fingerprint, the fingerprint is an input. It will try to find out, associate it with the fingerprints which it is already trained into. समझ में आ गया? Another is the recognition of alphabets. It is trained to read A. Imagine it is being trained to read 26 different handwritings of A. So it is like auto-associative. It is associating with its own. A के साथ ही उसको associate करना है. Whereas fingerprints and name of the person is a bidirectional associative or hetero association. Fingerprints एक set है, name of the person another set है. Whereas A is, it has to associate it with A only. So it is auto-association. So these Hopfield networks are all associative memories where it will remember the already trained activities, trained memories, so that it will remember. These networks can remember. Okay? Now let me go for the next tool which we were talking about as fuzzy logic. See, I told you neural network, fuzzy logic are the different tools of soft computing techniques. So fuzzy logic, what will you think of or remember when we hear the word fuzzy? What do you mean by fuzzy? कुछ भी आइडिया नहीं है. What is it?
Something which is not very precise.
Something, it is very correct. Something which is not very clear. Something which is not very clear. Now, what is it? Why do we require it? See, but when we talk about logic, when we hear the word logic, logic means it is very clear. Na? Logic word means it is the person, ye banda bada logical hai, means he is very clear about it. So now, when we say about logic, we have two words, binary logic, 0 or 1. The logic is true or false. But when we think about human thinking, simple logic is true or false. When it comes to human thinking, we always have a concept of partially truth. No, if I say Anju is beautiful, I cannot say it is true. if I say this comment, Anju is beautiful, all of you will have a different opinion or different value of truthfulness to it. If I say, if you agree fully, you give 1. If you do not agree, you give 0. And all your agreement can change between 1 and 0, 0.8, 0.9, 0.3, 0.4. You all can give values and you all will give different values. So the human thinking is always having partial values. That means it is a multi-valued logic between 0 and 1. It is a multi-valued logic between 0 and 1. Okay. If I ask you, what is the temperature today? How is it outside today? AC में हमें कुछ पता नहीं चलता है. How is it outside today? What about others? Will you say 29, 30, 39, 40? You may say it's very hot, madam. Not at all good, humid. You may again compare with Delhi. Delhi तो बहुत अच्छा था, बारिश हो गया था, इधर तो बारिश ही नहीं हुआ. So we always have a not clear output thinking. Okay, so how can we define that human fuzzy thinking into mathematical values or to machines? See, one single example I tell to all my students is about a furnace. See, you must be very comfortable about. Usually we have furnaces in industries and of very high temperatures. Like imagine one furnace is working of 700 Celsius to 2700 Celsius. Imagine, and 2700 Celsius is its highest temperature, and 700 Celsius is the lowest temperature. So if I ask the foreman who is working on it, वो मुझे बोलेगा मैडम ठंडा पड़ा है, furnace ठंडा पड़ा है. What is that ठंडा? 700 Celsius. See the word he uses. Thanda is the word he uses for 700 Celsius. So we use linguistic terms to define. Got my point? Linguistic means language values. Whereas the actual crisp value may be different. Okay? Actual crisp value may be different, but we think in those terms and define in those linguistic terms. How can we convert those linguistic terms into machine terms? Okay, that is actually fuzzy logic. Okay, we'll come to that. This is initiated in 1965 by Lofty Sadeh, Professor, Computer Science, University of California, Berkeley. Okay. This is conceptually very easy to understand, flexible. Here also, this is tolerant of imprecise data. One very important advantage of this is non-linear functions of arbitrary complexity can be modeled. I don't know how many of you have modeled a non-linear system. How will you model a non-linear system? By means of ordinary differential equations, partial differential equations, and there we have different assumptions, and then we apply Laplace transform to it. Okay, then we have assumptions, we have constants, we have uncertainties. So here we convert those nonlinear functions or that system into expert values using if, then, else. We convert the properties or the working of that system by using if, then, else equations, sentences. Okay, that is how we model. So this is very easy modeling than nonlinear functions. So to understand fuzzy logic, I'll start with the concept of set. We are all very clear about set and Venn diagrams. See, in a Venn diagram, the rectangle represents the universe and the sets, groups are defined by elliptical forms in between. And as we all know, they show that is a set. And the member of the set will be a member within the set, and not a member means he will be out of the set. Okay, so we have membership values 1 or 0. But in fuzzy, it does not have that crisp or clear boundary. All the members are either members or not members. There are partial membership functions also. Okay, partial membership functions also. Okay, that is why I have taken this example. This is an example of a crisp set. The 1 to 10, numbers from 1 to 10 is the universe, and a set is the numbers between 5 and 8. So the numbers have a membership value. 5 is having a membership value 1 because it is the member of the set A. Whereas 1 is not a member of set A, so it has a membership value 0. So we define a membership function like this, where you can see that 0 to 5 values have 0 value, and 5 to 8 has value 1, and 9 and 10 has value 0. Because 5 to 8 are the members of the value. So this is the crisp set. Now I am taking another example, a set of young people. Okay. Now here, where will you define the boundary line of young? आजकल तो बहुत ही ज्यादा ही हो गया है, यंग तो सबको यंग ही दिखना है, कोई ओल्ड दिखना चाहता ही नहीं है ना? हम कलर करेंगे, ये करेंगे to show that we are very young. Okay, so here also, where will you demarcate that set of young people? So it is a very fussy thinking. You cannot define. So there are some on the borderline which I am defining here as between 20 and 30 are young, and out of 30 they are old. Okay, leave it. So now here that 20 to 30 have a partial membership function. They are on the border. Not member, or they are not members also, and they are not non-members also. They are partial membership functions. So a fuzzy set does not have a clear-cut boundary. Now in this membership function itself, I made one set a set of young people. I can make a set of middle-aged, I can make a set of old, I can make a set of very old. Depending on the age group, I can make fuzzy sets, or I can make membership functions of the age group of people. So age is the linguistic variable, and young, old, very old are the linguistic terms. So if the parameter is temperature, so temperature is the linguistic variable, and cool, not very cool, medium, very hot, hot, those are linguistic terms. And now we can define. It's like I told you about a furnace, 700 Celsius to 2700 Celsius. So 700 is actually thanda, cool. So you define it as per the definition, like we say. So here the range is from 700 to 2700. 700 is the cool, whereas 2700 is very hot. Got my point? So the range and the temperature parameter is defined into its membership functions. Okay, got my point? So what all I have told, I have again written it here. I'm not going to read through. These membership functions have some shapes. It can be a triangular membership function. It can be trapezoidal, Gaussian, bell, or any other shapes also. What is the meaning of it? If I say it is a triangular membership function, what is the x-axis? X-axis are the members. Age, I told you, or temperature, I told you, that will be shown on the x-axis. What is the y-axis? Membership value, 1 or 0. So what do you mean by when I say that I am representing it by a triangular membership function? When I represent it as a triangular membership function. Huh? What is the meaning of it? X-axis are members, y-axis are the membership values. So you have various membership values for all the members. Okay, different members have different membership values, and only one member has membership value maximum. The maximum value, whatever it is, 1 or 0.8 or 0.9, is only one member is having that. That is the meaning of it. If it is a trapezoidal, what is the meaning? More than one members. More than one members have membership, maximum membership value. What about Gaussian? What about Bell? Maximum membership functions कुछ लोगों को है और उसके nearby भी बहुत लोगों को है, than having very low membership values. So various types of membership functions, this can be represented by various types of membership functions. It means that means the membership values of the members. Membership values of the members for a particular parameter. For a particular parameter. Okay. Whenever we define membership functions like this, we overlap the membership functions. We overlap the membership functions. When they say that if you overlapping of these membership functions, the control problem, output of the control problem will be very effective. Okay. Now I will take a simple example of a fuzzy control. Take a simple example of a fuzzy control. Fuzzy logic can be used for various applications nowadays. Even in optimization also, fuzzy is applied. Here I am giving a simple example on fuzzy control. Whenever we have to define a fuzzy control system, any control, any control is actually input, a black box, and an output. We have inputs given to the box, and that box is having the transfer function, whatever it is, GS value which we have, and we have the output. That is the normal representation of any control system. Fuzzy control system also is somewhat similar. You have inputs and you have outputs. What is happening within? Okay, so here, instead of giving crisp inputs to the control system, we give fuzzy inputs to the control system. So what we do, we convert the crisp inputs into fuzzy inputs. How do we convert? The conversion of the fuzzy input, crisp input to fuzzy is known as fuzzification. And that is the same which I have told you about the fuzzy sets. जो पीछे मैंने आपको ये दिखाया. So each of the input, उसका range आपने decide किया. उसकी membership functions आपने linguistic terms, like cold, cool, nominal आप decide किया. Then this process is known as fuzzification. Got my point? Your control problem, imagine, have 2 inputs and 1 output. So both the inputs and the outputs and the ranges are divided into fuzzy sets by means of linguistic terms like this. Is known as fuzzification. Okay. Now using these linguistic terms, we make a rule base. We make a rule base. Rule base means if the temperature is low and the humidity is also low, then the AC may be switched on. Off. I've written a simple control of an AC. You can write more equation rules like this. The rule AC की on off की control को आपको temperature और humidity की basis में if statements लिखने के लिए बोल दिया, आप सब लोग बहुत अच्छा से लिखेंगे. Why? Because you're experts. हमें यूज करना आता है, हमें उसका कंट्रोल भी लिखना आता है. Can we not do it? So I am not modeling the AC. कोई non-linear system, differential equation, कुछ भी नहीं है. AC की 0 to 1 की वैल्यू पे मेरे को उसको कंट्रोल चेंज करना है, depending on the value of temperature and humidity. Could you get the point? Will you be able to write equations, write rules? So this is an expert rule base. If I have to control the furnace की control को करना है, so मुझे कुछ नहीं आता, मैं किसके पास जाऊंगी? मैं वो फोरमैन के पास जाऊंगी. बता दो आप इसको कैसे कंट्रोल करोगे? And he is the expert. So he has some conditions where he changes the valve. And he will write it by simply writing if, then, and else. So that is the rule base. So first आपको input output का falsification करना है, आपको rule base बनाना है और expert rules बनाना है. Now you find the rule evaluation. For a particular value, what will be the output? जो फसी inputs है, फसी rules है, इसलिए output will also be in fussy. So conversion of that fussy into crisp is known as defussification. Output of that fussy, conversion of that fussy output to crisp values is known as defussification. Got my point? First fussification, then writing the rule base, and then evaluation of the rule base, and then finding the crisp output by defussification. Okay, now I'll take a simple example of balancing a pole on a mobile platform. To balance a pole on a mobile platform, the platform is moving. The speed of the platform is the one which I have to control depending on the position of the pole. Whether the pole is, what is the angle between the pole and the platform and the pendulum, and angular velocity of that angle, and the output is the speed of the platform, how I move it. Okay, so these are the two inputs and one output. So what is the first thing we have to do is fussifying this, knowing the full range of it. So angle ka range, angular velocity ka range, maximum and minimum values, and the speed of the platform ki maximum and minimum values, we convert it into simple intuitionary methods of defussification. मैंने इधर triangular membership functions use किया है. You can use trapezoidal or any other membership functions. So मैंने 3 membership functions बनाया है, linguistic terms बनाया है, negative high, negative low, zero, positive low, positive high, for all these 3, and then I will go for the rule base. If angle is 0 and angular velocity is 0, then speed is 0. If angle is 0 and angular velocity is negative low, then speed is negative low. So writing a list of rules which will satisfy the condition or working of that system to the fullest extent of its range. तीनों का range full लेना है. हमने इधर जो भी नेगेटिव हाइट टू पॉजिटिव हाइट की जो भी वैल्यूज हमारा रेंज में यूज किया है, ये पूरा यूज करके हम लिखो. सो देर आर 5 each. I think we can write around 25 to 30 equations. Equations नहीं है, rules. Here I have written only 7 or 9. ठीक है. These rules many a time when you write it ना, you may come into confusion सा हो जाएगा, मैंने लिखा कि नहीं लिखा. So writing a table will be better for you, so that you will see that मैंने ये rule लिखा है, ये rule लिखा है, and it is very clear and it is in a tabular form. Now this rule, we are going to evaluate the rule. What is rule evaluation? See, like I told you, rule evaluation is always on the basis of the actual input. Now here I have two actual input values of angle and angular velocity. आप इधर देखो, see here, this is the actual angle value and this is the actual angular velocity value. So this angle value is intersecting these two linguistic membership functions, 0 and positive u, angle. And angular velocity is intersecting 0 and negative u. Even though I have written 25 equations, 25 rules, only the rules which involve these linguistic terms, a actual value, जो linguistic terms में involve होता है, 0, positive low, negative low and 0. ये जो rules involved, यही rules involved होएगा. अब देखो, what are all the rules? If angle is 0, angular velocity is 0, then speed is 0. Got my point? And फिर क्या होगा? If angle is 0, angular velocity is negative low, then speed is negative low. आगे ना, ये 0 का 2 रूल हो गया. अभी if angle is positive low, angular velocity is 0, then speed is positive low. If angle is positive low, angular velocity is negative low, then speed is 0. So these rules which involve these linguistic terms only will be evaluated. कुछ books उसको fired भी बोलते हैं, rules fired. So here we evaluate these 4 rules. See how I evaluate these rules? See, what are the values at which this is intersecting? अब इधर पीछे देखो, ये इधर 0.75 पे वैल्यू है, इसको इधर 0.25 वैल्यू है, here it is 0.4, here it is 0.6. So these values are important. Now 0.75 or 0.4, if angle is 0, angular velocity is 0. So इसकी minimum हम लेंगे 0.4. Okay? अगला rule, if angle is 0, angular velocity is negative low. अब इधर देखो, angle is 0 पे 0.75 है, angular velocity पे it is 0.6, negative low का इधर 0.6 है. देखा? वो ये 0.6 है, a 0.75 है, उसकी low minimum value is 0.6. So we take value means what it is, membership values है. वो membership values की minimum लेके हम speed के लिए values बनाएंगे. And all these 4 rules, अब देखो these 4 rules से जो speed की output आया है, this will be combined together. When we combine together, we get a geometric shape as the output. हमें कोई crisp output नहीं मिलेगा. ये actual angle और actual angular velocity का क्या output चाहिए, हमारा कोई output नहीं मिलेगा. Now getting the crisp value out of this geometric shape is the process called as defussification. And the common method of defussification, we call it as the center of gravity method. And here the center of gravity of this geometric shape, which is that black color geometric shape, वो कहाँ पे है? That is the, ये देखो red point इधर देखो, उसकी corresponding speed है final output. Are you clear? So this calculation process is really a tedious calculation. मैंने कोई calculation आपसे कराया नहीं, I only explained it. Here हमें MATLAB toolboxes का utility होता है. MATLAB fussy toolbox में इसका पूरा GUI है. वो GUI से we will be able to do the calculations. It is not that you have to do all the calculations, because MATLAB is a very useful tool, is a tool where you can do this calculation. But then what you have to do, you should know how many inputs, what range of inputs, what are the different membership functions, what are the rules which we have to make. So in that fussy GUI, you have facilities of writing the rules, calculating the rules, writing the membership functions, making the fussy inference system, all those are there. So you take it, you will get the output. Okay? So मैंने अभी तक non-stop neural network और fussy logic explain किया है. Now if you have any doubts, we can have some time, so that means I can answer your questions, and I'll give you some time to think also. Any questions? Yes. Yes. Which sender you are from?
I'm from Sigmoid University, Jaipur.
Anji.
Ma'am, this you were saying about inverted pendulum method of.
Yes. Inverted pendulum is the actual application.
So why it is called inverted pendulum? Because I couldn't get that.
See, actually, what is that inverted pendulum problem? Problem is to balance a pole on a mobile platform that can move in only two directions, to the left or to the right.
Yes, ma'am.
So here there is a pole and it is balanced on a single platform. So the pole can move only in two directions, to the left or to the right.
Okay.
And the platform also will move only in two directions. So actually, like a pendulum which moves in only two directions, the pendulum is always downwards. Here it is upwards. So we call it as an inverted pendulum. That is why it is called as an inverted pendulum. It is actually a pole on a moving platform, and the platform is moving only into two directions, to the left or to the right. So the pole, to balance on the platform, we have to think of how far the pole is falling down. Pole will always fall down. It will not be it will not stand straight over there. So to balance that, we have to move the platform. That is why it is known as inverted pendulum.
Yes, ma'am. But how is it related to the fussification method?
See here, what is the crust of a control problem? See, I have some inputs and the output. Inputs are the angle values and the angular velocity values. Output is the speed of the platform. So for a particular angle value and an angular velocity value, what should be the speed of the platform? So the crisp value of the actual angle, here you can see the actual angle value. Can I show this thing? So here there is a crisp value of the angle and the crisp value of the angular velocity. What will be the corresponding actual speed value? So for that, we have to go for the actual speed value. That we have to find out. So
okay, I understood.
So now to find out that actual value, we go for these methods. Here the advantage is that you don't have to write big equations, you don't have to solve the equations, find the values. By simply defining it into if-then values and evaluating the rules, we will get the actual value of the speed.
Okay, okay, thank you.
Okay, any other questions?
Hello, ma'am. Hello.
Yes. Yes.
Yeah. Good morning, ma'am. I have a questions like you have.
Please tell which sender. Wait, 1 minute. Which sender you are from?
We are from MBSIT, ma'am.
Okay. Okay.
Now you have explained 4 types of membership functions. I would like to ask you, how can we choose out of these functions?
See, actually, I tell you, depending on the situations. See, many a time for simplicity, we use triangular membership functions and trapezoidal membership functions. Depending on, I told you, triangular membership function means only one member is having the maximum value. And trapezoidal means so many members have the maximum value. So if sometimes for a temperature, it is a varying temperature. Or you, in a case you know that the temperature is not varying, it remains constant, then you can go for a trapezoidal membership function. No problem in that. Depends on what is the situation or what is the control problem you are doing. Okay?
All right. Thank you. Thank you, ma'am.
What's your question? See,
Hello.
1 minute. 1 minute. Let me ask the question from the sender here. Single layer is having only one layer of neurons. See, there are more number of neurons, but the neurons are arranged in such a way that all the inputs are supplied to the neurons, and each of the neurons only one output is taken. So here the number of neurons is defined in by means of that how many outputs you have. See, if a single neuron can have only one output and more inputs. That is the neuron property or the characteristics of a neuron. So if you have 3 outputs to be taken, so you require 3 neurons in a single layer arrangement, But because we are giving all the inputs to all the neurons, all the inputs the first neuron also, all the inputs the second neuron also, all the inputs the third neuron also. So the number of inputs is immaterial of the number of neurons actually in a single layer system. You can give all the inputs to all the neurons, and you will have a weight matrix in that case. For one input itself, you will have 3 values: W13, W12, W11. Got it? So you will have a weight matrix over there. All values will be multiplied. But then, depending on the outputs, you will have a number of neurons there. But in multi-layer, the number of input neurons will depend on the number of inputs of the system. You have 5 inputs, means you have 5 input neurons. You have 3 outputs, you will have 3 output neurons. Got my point? And now you will have more number of hidden layers and more number of hidden neurons. The number of hidden layers and the number of neurons or hidden neurons, there are no hard and fast rules or thumb rule to decide it. So many a time we make use of MATLAB and use a hit and trial method to find out the number of hidden layers and the number of hidden neurons, which will be better and things like that. Here also we use, because it is a decision-making system, we use fuzzy for deciding how many number of hidden layers and hidden neurons. In between we use fuzzy systems, so that with that if then rules, we can find out the number of hidden layers and hidden neurons. So then it becomes a neuro-fuzzy system. So such things, hybrid systems are also available. Functions of hidden layers are simply to transfer one layer output to the other layer to the other layer. That's all. And we can have different activation functions in these different layers. Whereas in single layer, you can have only one activation function. That activation function is not giving you the output, means what will you do? So in a hidden layer, you can have different hidden layers means you can have different activation functions so that you feel that you can get a right output. Okay. Thank all the participants at the different centers, and I'm so happy seeing the response from all the participants and from the participants here also. I'm happy. Thank you very much. Thank you.